Hello everyone. This video tutorial is solution of problem 2.56 of chapter 2 free vibration of single degree of freedom system from mechanical vibrations by S.S. Rao 5th edition. The statement of problem is a helical spring made of music wire of diameter D has a mean coil diameter of 0.5625 inch and n active coil turns. It is found to have a frequency of vibration 193 Hz and a spring rate 26.4 pound per inch. Determine the wire diameter and the number of coils, assuming shear modulus G 11.5 into 10 to the power 6 psi and the weight density rho is 0.282 pound per inch cube. The spring rate and frequency, these are the formula for spring rate and frequency, and here W is weight of spring. So weight of helical spring is usually its formula you can find from machine design book, and its formula is weight of active turns. So weight of the spring is pi by 4 d squared into pi d into n into L. So you can find this formula from any machine design book. So this is from chapter 13 spring design. So here you can see like if you have to find weight of the spring, so you need to find out its volume, because volume times by density, that will be its weight. So in this formula, this W meant to be mass, or otherwise uh, this weight is equal to volume times by density. So that volume times by density, that will give you mass, and times by G. So it is weight. But here in this formula, that W is meant to be mass, because it is K, usually natural frequency is K over M. So here W meant to be mass. In this problem, wire diameter lowercase d and number of active coils, they are required. So first I'll use that K formula. So spring stiffness formula for, and then I am going to make d raised power 4 over n as a subject in this, from this formula, because both are unknown, and then it comes as 8 dq k over g. So outer diameter of spring, or mean diameter of spring, is given as 0.5625 inch. Then K is given as 26.4, and then modulus of rigidity is 11.4 into 11.5 into 10 to the power 6. So when I'm going to substitute all that from values there, so I'll get d raised power over n as 3.2686. 1 into 10 to the power minus 6. So I'll get uh, this value. So I am going to save in calculator as A. This value I'm going to save it in calculator as A, because I can use it again. And for that purpose, if you have the calculator, so shift, recall, and then A, so you can save it. And if you're using SUFX 991EX, so with the store, and then here you have A, so you can store it. Now the next one, this natural frequency formula, F is equal to half radical kg over W. So I'm going to simplify it as 2F is equal to radical kg over W, and by scaling both sides 4F squared is equal to kg over w, and then rearranging that 4f squared into w is equal to kg. Now, in this formula, as I told you that W is meant to be mass, so I am just using mass here with W in terms like I'm not going to put G here. So now I can substitute the value of W here. So after substituting value, it is pi by 4 d raised by 4 into pi d into n into rho is equal to kg. And this 4 is being cancelled with the 4 in the denominator. So it is comes as pi is f squared into pi is pi squared, then d squared, then d n rho is equal to kg. So now in this case, lowercase d and n, they are required. So I'll make them as subject. So you will have kg, f square in the denominator, pi square in the denominator, d and rho. So now k for the spring is given as 26.4. Value of g. So value of g in inch per squared is 386.22, and then frequency is given as 193. Wire diameter, spring diameter or spring coil diameter is 0.5626, and the weight density is given as 0.282. So after performing calculation, so you will get it as 174.845 into 10 to raise power minus 3. So because I have to use it again, so I am going to save it as B in calculator. So now I have two equations here. One is d raised power 4 over n, and the other one 2 is d squared n. So now from here I can make any n or d in both of the equations as subject, and then I can solve for. So from equation 1, I'll have d raised per 4 over n is equal to a. A is saved in calculator, otherwise you can use that number here, these numbers. So n is d raised per 4 over a, and here from equation 2, d square n is equal to b, and here I can make n as subject, so it will become b over d squared. And then further I can make them equal, those values. So it is d raised by 4 over a is equal to b over d raised bar, and then this can be simply rearranged that. So is d raised bar 6 is equal to ab, a times b, and then d is a times b into a times b into 1 raised bar 6. So then by substituting values of a and b, or these exact values of a and b, so you can find out the value of d then. Okay, so a and b, you can recall these values from the calculator where you have saved. So with alpha and a, you can recall it times alpha, b, you can recall it, or otherwise here you have alpha, and then here is a, here you have alpha and b, so you can recall those values, or otherwise you can substitute values of uh, d raised by 4 over n from equation 1 and d square n from equation 2. So here you will get d as 91.0967 into 10 to raise power minus 3 inches, and then you can substitute the here this d value in any of equation 1 or equation 2. Let's say if I have to use it again, so to find value, so I'm going to save this in calculator as C. So then I have I can use that n equal b over d squared. So d is now saved in your calculator as c, or the values which you have, b value over c. So you can find out value of, so you'll have value of n after substituting b as 174.845 into 10 to the raised power 3 over c as 91.0967 10 to the raised power 3. So it comes as 21.069 and 21.0692, because number of turns are always, they are rounded. So here I can round it as number of turns as 21. So the diameter comes as 91.0967 into 10 to the raised power 3, and n is 21 turns. So that is the solution of problem 2.6. Thank you very much for watching.